All right, today, you guys, we've got a few different concepts we're going to cover very quickly. Again, trying to keep it under that 10-minute mark. We're looking at positive and negative numbers, adding and subtracting, multiplying and dividing, combining like terms, and then a brief introduction to scientific notation. So if you're struggling with any of these things, you're in the right place. So like terms, again, when we're combining like terms, a lot of times on test questions, we're not even solving for X or Y or A, B, whatever. We're just combining like terms. So in order to combine those like terms, add or subtract them, we'll look at when we're multiplying or dividing here in a second, but in that case, it doesn't matter about like terms. Like terms is usually when we're collecting or combining using addition or subtraction. So in order for them to be considered like or the same like terms, we need to have the same variable and to the same degree. So for example, down here, we have all of these terms have an x with them, but x cubed, x to the power of 1, or just x, and then x squared are not the same terms because they don't have the same value or the same degree up here, the same exponent. So I go through here and I see anything that I have in common. So I like to draw it out like this. Well, that's 2x cubed. Okay, and then I see another x cubed right here. Oh, and again, there's no coefficient, but if it helps you, draw in the 1. I have 2 here and 1 here. I'm adding, pay attention to the sign. So 2 plus 1 is just 3. It's still x cubed. Next, I want to go my next degree. I could start with x, but we want to write them in descending order, just out of habit. Again, it's not incorrect to do it the other way, but it's just going to help us down the road. So I have a 2x squared. Okay, where do I see another? Right here. And another positive 2x squared. So positive 2 plus 2 is 4. So 4x squared. Now, the x squared doesn't become x to the power 4 or anything like that. It's just that if I have 2 of something and I add 2 more of those same things, I now have 4 of those things. In this case, x squared, or in this case, x cubed. And then I have 5x over here to this minus 2x, 5 minus 2x, 5x minus 2x, 5 minus 2 is 3. So it's a positive 3, so plus 3x. And I'm not multiplying x times x or anything like that. Again, this is as far as I can go. So a lot of times these like term problems I think are simpler than we're anticipating. I've seen people sometimes set them equal to each other, try and combine these somehow. There's nothing else we can do. That's as far as we can go. So we're done. So like terms, they got to be the same variable in the same degree. Pay attention to your signs. Am I adding or am I subtracting? Okay, and then just combine your like terms, reduce, and then if you can, it's going to help you down the road, write them in descending order. So this had a degree of 3, x cubed. This was x squared, and this was x to the power of 1. And then if we had some sort of constant out here, some number, we would do that at the very end. And it's all addition, so we can technically move them around, and it's the same thing. It's just best practice for when you guys get into Algebra 1. All right, when we're reducing, in these like terms need to have the same base. So again, a to the power of 2, a to the power of 1, b cubed over b squared, and then c over c. So we'll see a lot of problems like this, where we're either multiplying or dividing. So we look at the same base. I have 2 up here, a times a, and I have a down here. So I could think of this as a times a, and one of these is canceled out. Or I can remember, well, same base, I'm dividing, so I subtract the exponent, so 3 minus 2 is 1. So again, you can do it either way. I subtract the exponents just to save work, but if you want to draw this out as a times b times b times b times c, that's fine. And again, this is all over this. So just because the b and the b are not directly over each other, that doesn't change anything. So I could redraw them being directly over each other, but I don't have to. So a squared over a, so that was just a left in the numerator, b cubed over b squared. So b cubed minus 2, because 3 minus 2, because I'm dividing, just becomes 3 minus 2 is 1. So b to the power of 1, or we can just call that 1. And then c divided by c just cancels out. So all of this reduces down to ab. Again, not solving for a and b, not setting it equal. That's as far as I can go. So we're done. Hey, now a brief introduction to scientific notation. We use scientific notation usually for really large numbers or really small numbers. You can use it for, I can write 250 in scientific notation if I want to, but I think that's going to be a lot more work than just saying 250. So it's usually for things in, the trillions or quadrillions, or in the trillionths or quadrillionths, talking about really small decimal numbers. So talking about the distance of stars or planets or something like that, we'd probably use scientific notation. We're talking about really small things under a microscope. They're really small, so we'd probably express those in scientific notation. So in this example, if I want to make this this is scientific notation. So my coefficient right here, I have a value in the ones place and everything else to the right of the decimal. I can't call this 0.23 or 23. It's got to be a decimal after the ones place, a value in the ones place. So my coefficient here has to be 1 or greater, can't be less than 1, and it can't be greater than 10. So I can't have 23 because that's greater than 10. I can't have 0.23 because that's less than 1. And so you'll understand the difference here in a second when we do a few problems. But in standard notation, times 10, it's always base 10 to the power of 5. You could write this out with 5 zeros, or remember that this exponent of 5, that would give me 5 zeros, just like when we talked about decimals to percents, multiply by 100. I have 2 zeros, so I move it 2 places to the right. Kind of that same concept here, but now in this example, it's a positive 5. So I'm going to take that 2.3 and I'm going to move the decimal 1, 2, 3, 4, 5 places, and that's where it would be now. And then I fill in those kind of grooves that I've drawn with zeros. So if I put my comma in there, it's 230,000. Again, that's not an incredibly large number. We could probably say 230,000, but this is just to give us practice with scientific notation. Now we will see some base 10 with negative exponents. It doesn't make the number negative, it just makes it very, very small. So again, 1.7, that's my coefficient. This decimal is moving 7 places, but since it's a negative 7, it's going to the left 7 times. 1, 2, 3, 4, 5, 6, 7. And then in those grooves, I fill in 0. So again, a very small number, but I can express it in scientific notation. So this is standard notation, just regular number, and then this is scientific notation. This coefficient can't be less than 1 or greater than 10. And we can also work with these numbers. We can multiply these, or we can divide them. Okay, so again, this is multiplication. This is just number times a number. So you can do it in standard notation, multiply them out, and then convert it back to scientific notation. Nothing wrong with that. It's just going to take a little bit more time. But what I do is I do 2 times 4. That's not too bad. And then 10 cubed times 10 to the power of negative 8. Well, since I'm multiplying, I add the exponents. So 3 plus negative 8 is the same as 3 minus 8, which is negative 5. So it becomes 8 times 10 to the power of negative 5. So we'll see these types of problems. Don't put in your calculator and give me 8e negative 5 or something like that. That helps you get your answer, but scientific notation, my coefficient needs to be between 1 and 10, and then base 10 time raised to a positive or negative exponent. Okay, we can also divide scientifically notated numbers. So again, just look at the coefficients first. 5 divided by 10 is 0.5. We'll need to work with that in a second. 10 to the power of 4 over 10 squared. We subtract, since we're dividing, 4 minus 2 is 2. Okay, now I don't leave it like this. This looks like scientific notation, and it's very, very close, but I need to write this as 5 times 10 to the power of negative 1, because that's going to move the decimal over here. Or you can say I'm multiplying by 10. I'm going to divide by 10, or take 1 away, okay, whatever's easiest. Or if you think of this number as this, 5 times 10 to the power of negative 1 times that 10 squared, still 10 to the power of negative 1 times 10 squared. Negative 1 plus 2 is just 1. Negative 1 plus 2 is 1. So 5 times 10. Again, that would end up being 50. So we'd probably just express that as 50. But you'll see some of these types of problems just to be working with scientific notation. The one with this is we had to convert it. We had to move the decimal to here because this is less than 1 right now. We can't just move the decimal and ignore this. We had to take 1 away from the exponent in order to keep it equivalent. Or if we remove the decimal, let's say it was 50 and we moved it to the left, we would be dividing by 10, so we would need to add 1 to the exponent. So just make sure they're staying equivalent. All right, and then looking at our positive and negative numbers. So again, on our number line, we have our integers 1, 2, 3, and then their opposites, -1, -2, -3. So when we're adding and subtracting these, so -2 plus 3, we don't really have a rule for addition and subtraction of a negative and a positive is this. It depends on the absolute value of this. 3, the absolute value of 3 is greater than the absolute value of 2. 3 is a positive number, so this is going to end up being positive. I don't even really think about that when I'm calculating. I just think about, well, -2, so I'm 2 left of the origin. This origin here, so I'm 2 left. I'm adding 3 to it. 1, 2, 3. So I'm going to end up at 1. And we get, this is addition, so I could rearrange as 3 plus -2 or 3 minus 2. Could obviously make it a lot easier since we're experts with working with positive numbers. Again, that would be 1. -4 minus -3. So again, I like to get to where there's just one sign between, one operation. Subtracting a negative, well, if I'm subtracting a negative, that's just the same as saying plus 3. So I'll just go ahead and write in plus 3. That makes it a little bit easier for me. Mentally, if you're putting it into your calculator, you can do either way. -4 plus 3, the absolute value of this is greater than the absolute value of this. So I know my answer is going to be negative. -4 plus 3 is -1. Look back at our number line. -4 plus 1, 2, 3, that's where we ended up. And I don't expect you to draw out number lines. In the book, it'll do, that drives me nuts, but it'll show problems like this to get you thinking positive and negative numbers. This seems very complex to just say 4 plus 2. 4 plus 2 is 6. We could do that in our heads since probably kindergarten. Okay, that's not too difficult. So they sometimes use the parentheses and the positive sign and the positive sign. I don't like that. If a number's negative, just make it negative. If it's positive, just write the number. If there is no sign, we know it's positive. But just be aware of that. If you see it in the book, it makes it, at least to me, look, it kind of muddies the water a little bit. 3 plus -2. Again, I like to have one sign. Well, adding a negative is the same as 3 minus 2. That's pretty easy. -5 plus -3. That's the same as -5 minus 3. So I'm 5 left of the origin. I go 3 more to the left. That's going to put me at -8. When I'm multiplying, -2, a negative times a negative is a positive. Again, we don't need to draw on the positive. So -2 times -3 is +6. Okay, so a positive times a positive, or a positive divided by a positive is always obviously positive. A negative times a negative, or a negative divided by a negative is positive. And then if I have one negative sign, a negative times a positive, or a positive divided by a negative, it doesn't matter where the negative symbol is. If I just have one, that's an odd number. So this works out to be negative. So the multiplication and division rules are the same for multiplying and dividing. Down the road, we'll probably only see 1 or 2 signs in the problems, but as we get down the road, you might see 3, 4, 5, 6 different signs. Just remember, if you have an even number of negative signs, so 2, 4, 6, 8, whatever, your solution is going to be positive. If you have an odd number, 1, 3, 5 of a negative sign, and you're multiplying and dividing, then your solution is going to be negative. So 2 is an even number. That's why it ended up being positive. 1 is an odd number. That's why it ended up being negative.